are there good examples of behavioral change, methods of inducing behavioral change in ordinary people, not just scientists? I don't have good data on this. It's a very important question. I think there's far more people here at Berkeley who are expert in these sort of issues than me. One example is the Google Power Meter, where what I've heard anecdotally is that people who use the Google Power Meter, which uses a clip-on device that talks to the internet through Google and shows you in your Google homepage graphs like my electricity consumption graph. Anecdotally, people who then get engaged in that of all types end up saving 20% on their electricity bills. So I think just having an engaging display that helps people compare one week with another is definitely a way of getting success. But maybe the best way to create behavioral change is going to be to use the media that are already used to make amazing behavioral changes. You see people wearing particular styles of clothing, baseball caps, Nike, and so forth, drinking particular drinks. Why? It's because of advertisers and role models such as sports heroes, inspiring everyone to go for particular behaviors. So I think there's a lot more to tap into than just the geeky solutions that I've been mentioning. So I think thermostats are wrong. We shouldn't have thermostats where you set a temperature. One thing that's wrong with this thermostat is it doesn't have any way of switching it off. This is my hotel room in Boston, and it right now is carefully pinning the temperature to whatever the thermostat is set at. There's no way I can tell it. I'm not actually there. So we've got to get away from thermostats and get people tinkering with their environment. And some storage mechanisms. So I'd like to say a little bit about storage. In Britain, electricity demand currently fluctuates every day. These are daily fluctuations. And gas demand for heating varies annually. This is 1 year's variation with great big spikes when the temperature is low. These are temperature graphs up here, and this is gas consumption going up into the 76s of kilowatt hours per day per person nationally, compared with a summer consumption of 32 kilowatt hours per day per person. So we have fluctuations, and we need to cope with them in some way. And on the electricity side, storage systems are an option, pumped storage systems like this one in North Wales. And heat storage, I think, is going to be a very important technology for this 2050 future that we're trying to visualize. If we can move heat, if we can have heat do time travel from summer to winter, that could really help out with the midwinter peak demand. And in Canada, there's a solar community where 50 homes are using extremely outsized solar hot water panels on their garages here to generate far too much hot water in the summer, and they pump the heat down into the ground and then pump it back out in the winter. So here's the hole in the ground, lots of holes 35 meters deep in a place with a radius of 35 meters or so, which has very much the same scale as the ice houses that used to be common around this part of the world. And it's got a similar function. This was for time travel of cold from winter to summer, of course. And there indeed used to be an international energy trade transferring cold on ships around the world. Norway used to export ice to London to the tune of 340,000 tons of ice per year. Okay, I've reached half time, and I'd like to offer you a quiz just to wake you up. I'm sure you've had a hard day, as I have. So I've got 3 questions in the quiz, and the first question is, in 2010, I'll give you a bit of information, the UK had 273 wind farms. Here's a few of them. I showed you data points from them a moment ago. The total number of turbines in those wind farms was 2,747. Question 1, was the output of all of those onshore wind farms bigger or smaller than the energy output of Sizewell B, the average annual output of Sizewell B? Have a chat to your neighbour, and then we'll have a vote on whether you think the answer is A, B, or C. They're about the same. Okay, time to vote. Everyone must vote, by the way. No abstentions are allowed. So votes for A, energy output of the wind farms was bigger than Sizewell B. Okay, grand, all right, that's about 50. Votes for B, energy output of Sizewell B was bigger. All right, that's about 500. And votes for C, they're about the same. Okay, that's about 200 odd. Okay, the C's have it. The correct answer is C. They're both producing on average about a gigawatt in power station units, or in my personal units, about 0.4 light bulbs per person on average. So multiply this wind farm here by 100 and put it alongside that one Sizewell B, and they're about the same as each other. Good, so that's an interesting thing. Question 2. Here's a statement about energy reduction. In trials that DEC has had access to, we find that when you put cavity wall insulation, you get the fluff man to come and put fluff in your walls, you get a reduction in heat consumption of your home by about 10%. And incidentally, another way of getting a reduction is if you forcibly turn someone's thermostat down by 1 degree at all times compared with what they would have had it at, then you'll get a 10% reduction in their energy consumption for heating as well. Question 2. Imagine that we get all homes to do that, to turn the thermostat down 1 degree, so reducing their heat consumption by 10%. How does the energy saved compare with one Sizewell B of energy output? Have a chat. Okay. Time for a vote. Votes for A, it saves more than a Sizewell B. Okay, that's 400 people. Grand. Votes for B, less than a Sizewell B. Okay, that's about 25. Votes for C, it's about the same. Okay, that's about 200 or so. And the correct answer is A. It actually saves quite a lot more than Sizewell B, roughly 3 times as much. So in personal units, it's 1.4 kilowatt hours per day per person. Okay, interesting. Energy saving has potential. That amazing technology, the thermostat, you grasp it and rotate it to the left. It does something. Technology is great. Okay, question 3. I told you about the onshore wind farms and Sizewell B. Now let's compare them with one other thing. Here's a blast furnace. The UK has got 5 blast furnaces. They make steel. The output of one blast furnace, like this one in the photo, which easily fits in a square kilometre, is 2.5 million tons of steel per year. Okay, that's very hard to comprehend because it's got millions in it. Well, one thing you could do with 2.5 million tons of steel is you could make 2.5 million new cars. That's the number of new cars that get onto the road in the UK in 1 year. Okay, so one blast furnace. Which is bigger, the energy output of the wind farms, which you already know about now, the energy output of Sizewell B as well. Which is bigger, that or the energy consumption of the blast furnace, which is mainly in the form of coal? Okay, have a chat. Okay, let's have a vote. Votes for A, the wind farms are bigger. Okay, that's about 40. Votes for B, the blast furnace is bigger. Wow, that's a lot. Okay, grand. And votes for C, they're about the same. That's about 100 of you. And the correct answer is C. They're actually about the same. So yes, very big. There's only 5 of them, bear that in mind. Very big, definitely on the scale of things we need to pay attention to. So industry is a biggie, but it's about a gigawatt of power, or in light bulbs, 0.4 light bulbs per person is one blast furnace. Okay, here's another thing for free, which is a gigawatt. The power going along one of these pylons, which these protesters are complaining about, is 1 gigawatt as well. So that's yet another thing. If you see one of these big monster pylons, that's a nice eyeful of 1 gigawatt. It's the same as the Sizewell B. It's the same as all the wind farms, all the onshore wind farms in 2010. We've had some heat pump experiments where we measure how well the heat pumps actually work in Britain, and the results were actually not very good. So these are some graphs showing results of not very good heat pumps. And so a member of my team, an engineer working for me, drafted, with the help of the industry, new standards for how to install heat pumps so that they will work well. And we just published those 2 weeks ago. So that's another project I've been really proud to be involved with. And hopefully heat pumps in Britain are going to start working significantly better.